In this video, you'll learn what does return expression inside the Lambda do, why it works like that, and how to safely use it for your purposes. Here we start with an example that sometimes might be really confusing. So this is the puzzler. This is the function that tries to duplicate all the elements except 0. And your question is what does it produces as a result? So because it's a puzzler, you might expect something unexpected as a result. So you can try to guess what's going on, and later we will discuss what exactly is happening here. So our options would be the list of lists is the result. The second option is the same list but flattened, just the elements. And the last one is an empty list. So the right answer here is an empty list, which is really unexpected. Sometimes if you expect, if you write this code and expect this function to be printing these duplicating non-zero elements. And now we're discussing what's going on here. Return in Kotlin always returns from a function marked with fun. That's something you may consider as a rule, and we'll discuss now why it happens like this. But that explains an empty list here as a result. So here, when the list finds 0 element, it returns an empty list, but it returns an empty list from the whole function. And that's why an empty list is printed out as a result. Why does it work like this? Why in Kotlin returns from the outer function? Consider the following example. When you have a regular for loop, and inside this for loop you use return. If you convert this for loop to using for each, then you kind of expect that return does functions the same way. So returns here, like in for loop, returned from the whole function. And now we are glad that now also returns from the whole function, not from the lambda. So that explains the motivation of why it works like this, because a lot of functions behave like language constructs, like for each, and we want to provide a similar experience. What can you do if you need return from Lambda? You can use labeled return syntax. So for instance, here labeled return will return from Lambda. And by default, you can use as label the function name that calls this Lambda. But if you want, you can specify any label name. So for instance, here we provide the custom name, just L, to label the Lambda, and you again can use labeled return. So this will be the solution using labels, and here we get what we expect, just the flattened list of duplicated numbers. There is another solution to the same task. Instead of lambdas, here you can use local functions, for instance, and then pass a reference to this local function. And in this case, return behaves as expected, because now returns from the fun keyword from the function. Another alternative solution would be to use anonymous function. So you can actually define this function just as a lambda when you pass it as an argument, and it is just an alternative syntax for lambdas. The alternative syntax which behaves the same, the underhood implementation and the compiled code would be the same, with only one difference, that syntactically now you can use return, which returns from this fun keyword. And again, you got what expected without any confusion. So you can know about this alternative syntax. You can just, if you don't want to introduce local function and invent a name to it, you can use it as an anonymous function. And here also returns from this anonymous function. And sometimes it's also possible to just avoid return. In this simple case, you can use if, and also you get what you expect as the result. This explanation of how to use return inside Lambda completes our discussion of functional programming so far. Later in the course, we'll return to the topic of operations on collections and discuss inlining and the difference between eager and lazy iteration. Our next module will focus on object-oriented programming in Kotlin, which has some small differences with Java.